3 nuclear reactors in France went dark this week, and not one of them was switched off because something broke. They were shut down because the rivers that cool them had grown too hot. Golfech, Bugey, Chooz, thousands of megawatts of the most reliable power humanity has ever built, defeated by the temperature of the water, in the middle of a record heatwave, at the exact moment millions of people needed that power to stay alive. And France is only where it became visible first. The same physics is loaded right now over the United States, where a record heat dome is building toward the East Coast. Because this is the part almost no one is saying out loud. The electricity we rely on to survive the heat is the first thing the heat takes away. Before we start, tell me in the comments, is your grid holding up where you are? Or have you already felt the strain this summer? Subscribe to the Quiet Archivist so you know the moment this story develops. Now let's get into it. Somewhere along the Garonne, the Rhône, and the Meuse this week, 3 of France's nuclear reactors stopped making electricity. Not because anything broke, not because of an accident, or a fault, or a warning light on a control panel. They were switched off on purpose by the people who run them, because the rivers that keep them cool had grown too warm to do the job. Golfech Unit 2, 1,300 megawatts of power. Bugey Unit 3, 900 megawatts. Chooz Unit 2, 1,450 megawatts. All idled. And at least 8 more reactors across the country were quietly turned down, running at reduced output, for the same reason. To understand why that is such a serious blow, you have to know what nuclear power means to France specifically. This is a country that draws the majority of its electricity from these plants, a larger share than almost any other nation on Earth. When France idles reactors, it is not trimming a minor contributor at the edge of the grid. It is pulling on the foundation. 3 reactors fully stopped, and at least 8 more throttled back adds up to thousands of megawatts of dependable, around-the-clock power removed from the system in a single stretch of days and removed at the worst possible moment, when the heat is driving demand upward and the country can least afford to lose a watt. The rivers did that. Not a war, not a fuel shortage, not a technical fault. The temperature of the water. Think about what that actually means for a moment. The single most reliable, weatherproof source of electricity humanity has ever built. The kind of plant that runs through blizzards and hurricanes in the dead of night without blinking, was defeated this week by heat. Not by a storm, by the temperature of the water. And it happened in the middle of the exact conditions where that electricity matters most. Because when a country is baking under a record heat wave, the one thing keeping millions of people safe is the power flowing to their air conditioners. That is the story I want to walk you through. And it is bigger and stranger than a single utility in a single country. Because the same physics that shut those reactors down is loaded right now over the United States, where a record-breaking heat dome is building toward the most densely populated corridor in the country. What is happening in France is not a French problem. It is a preview. Here is the part that should stop you cold. The reactors were not shut down to protect the reactors. They were shut down to protect the rivers. French nuclear plants pull water straight out of the river to cool themselves, and then they send that water back, warmer than it started. On an ordinary day, that is fine. The river is cool enough to absorb the extra heat and carry it away. But when the river itself is already running hot, adding more warmth to it would push the water past the legal limits set to keep fish and everything else living in it from dying. So the operator has a choice: cook the river or shut the plant. This week, France shut the plant. And then it did something that tells you exactly how serious this has become. Over the weekend, the French Economy Ministry issued an exemption for the Rhône around the Bugey plant, formally allowing warmer water to be discharged, quote, to ensure the security of the power grid, end quote. That waiver runs until July 20th. Read that again. The government temporarily suspended an environmental protection it normally enforces because losing the electricity was the greater danger. That is not a routine maintenance note. That is a country being forced to decide which thing it is willing to sacrifice, and choosing the river. France is not alone in this squeeze. It is simply the place where the strain became visible first, in the most dramatic form possible. Across the same continent, the same heat has been rewriting temperature records for weeks, and across the Atlantic, the United States is walking into its own version of the same test. When two of the world's largest developed economies are pushed against the limits of their power systems by the same weather in the same stretch of a single July, that is not a run of local bad luck. That is a pattern announcing itself. And the spine of that pattern is the uncomfortable fact we're going to keep circling back to tonight. The electricity we depend on to survive extreme heat turns out to be vulnerable to the very heat it is supposed to protect us from. We are going to get into why a heat wave can strangle a nuclear plant, what is happening over America right now, and why every forecast on the table says this is only the beginning. But the question underneath all of it is the one I cannot stop thinking about. What happens to us when the very thing we depend on to survive the heat is the thing the heat takes away first? Let me explain the machinery, because once you see it, you cannot unsee it, and it changes how you read every heat wave for the rest of your life. A nuclear reactor is, at its core, an extremely sophisticated way of boiling water. It splits atoms, that releases enormous heat. That heat turns water into steam. The steam spins a turbine, and the turbine makes electricity. But here is the catch that nobody puts on the brochure. To keep that cycle running, you have to get rid of the leftover heat at the other end. You have to take the steam and cool it back down into water, so the whole loop can start again. And to do that, you need somewhere to dump all that waste heat. For many of France's plants, that somewhere is a river. The plant draws river water in, runs it past the hot side of the system, and the water carries the excess heat away as it flows back out. It leaves the plant warmer than it arrived, sometimes by just a few tenths of a degree, sometimes by several degrees, depending on the site. This is the quiet, invisible bargain every riverside power plant makes with the world around it. And that bargain has a hard limit written into law, because a river is not just a coolant. It is an ecosystem. Push the water temperature too high, and you starve it of oxygen, and the fish and the insects and the plants that live in it begin to die. So France requires its operators to monitor the temperature of the water they send back, and to throttle down or stop entirely when the discharge would push the river past the threshold. There is a second, quieter penalty hiding inside the same physics, and it applies to every thermal power plant on the planet, not just nuclear ones. Every plant that makes electricity by boiling water is a heat engine. And a heat engine only works because heat flows from something hot to something cold. The bigger the gap between the hot side and the cold side, the more efficiently the machine runs. But when the cold side, the river, the air, the cooling water, warms up, that gap narrows and the efficiency drops. So a heat wave does not just threaten to break a legal limit. It makes the plant worse at its job, squeezing a little less power out of the same fuel on the very day the grid is screaming for more. The heat attacks from both ends at once. It warms the coolant toward the legal ceiling, and it steals efficiency from the machine. Not every plant cools itself the same way, and the difference matters. Some plants use what is called once-through cooling, drawing river water straight through and sending it back warmer. Those are the ones most exposed to river temperature, because the river is doing all the work. Others use closed-loop cooling towers, the giant hourglass-shaped structures you have seen in photographs, which recycle their water and shed heat by evaporation into the air. Towers are less sensitive to how warm the river already is, but they consume water by evaporating it, which becomes its own problem during a drought. There is no version of this that heat leaves alone. Every cooling method has a temperature it fears, and this summer is finding all of them. This is not the first time Europe has run into this wall. Back in the 2003 heatwave, one of the deadliest in the continent's modern history, France was forced to curtail nuclear output for the same river temperature reason, and it has happened again in the hot summer since. What is different now is how often it is recurring, and how early in the summer it is arriving. Notice which rivers we are talking about, because the choice was deliberate, and it has come back to bite. The 3 reactors idled this week sit on the Garonne, the Rhône, and the Meuse. Major rivers, chosen precisely because a big river carries a large, steady flow of water that can absorb a plant's waste heat without warming too much. That was the whole logic of siting a reactor on a great river. Reliable cooling, year-round. But that logic assumed the river itself would stay cool. In a summer like this one, the assumption breaks. The same big rivers that made these sites attractive are now warming up along their entire length, and the plants that were built to lean on them have nothing left to lean on. The infrastructure was engineered against the climate of the past, and the climate of the present is walking straight through the gap. That is the thread that runs through this entire story, from the reactors in France to the grid in America. The machines are fine. The world they were built for is the thing that changed. Now hold that mechanism in your mind and add one ingredient. Add a heat wave. When the air is running 10, 12, 15 degrees above normal for days on end, the river warms up all on its own before the plant ever touches it. The water coming in is already close to the ceiling, which means the plant has almost no room left to add its own heat without breaking the limit. The margin the entire system depends on simply evaporates. And this is the thing I need you to hold on to, because it is the spine of everything we are talking about today. The hotter it gets, the less headroom these machines have. At the exact moment, the world needs them running at full tilt. That is why the Bugey exemption matters so much. It was not a technicality. It was France admitting, out loud and in writing, that the normal rule could not hold, that the grid needed the power more than the river needed the protection, and that for 6 days it would let the water run warmer than the law allows. A week ago, we looked at how fragile the power grid has become under a stacked set of pressures, and this is that fragility made physical. It is one thing to talk about a grid under strain in the abstract. It is another to watch a government sign a piece of paper that says, in effect, we will heat the river because we cannot afford to lose the plant. Here's what makes this genuinely unsettling, rather than merely inconvenient. This is not a malfunction. Nothing failed. The system worked exactly as designed. It refused to cook its own rivers, and in refusing, it revealed that its safety margin disappears on precisely the days it is needed most. And if that is true of the most weather-hardened power source we have, in a country that gets the majority of its electricity from these plants, then the obvious next question is what happens when the same physics arrives somewhere with far more people and far less slack. Which brings us across the Atlantic to a ridge of high pressure now swelling over the United States. While those French reactors were going quiet, something enormous was building over the western United States. Meteorologists measure the strength of a high-pressure ridge by the height of the air pressure surfaces overhead, and the number attached to this one is 594 decameters, an unusually powerful summer ridge, the kind of atmospheric dome that traps heat underneath it like a lid on a pot. And on Sunday, July 12th, that lid produced something the record books had never seen. All-time record high temperatures fell across parts of the Great Basin and the northern high plains, according to the National Weather Service. Not records for the date. All-time records, the hottest ever measured at those locations, in any month, in any year on record. The scale of it is written into the alert map. As of Monday, there were 236 active Weather Service alerts across the country, and the overwhelming share of them were about heat. 19 extreme heat warnings, 8 extreme heat watches, and 33 heat advisories, stacked from the Great Basin through the plains and reaching east. In Bismarck, North Dakota, the heat index was forecast to reach between 100 and 110 degrees Fahrenheit. In Grand Junction, Colorado, 100 to 106. In Riverton, Wyoming, 100 to 105. In Aberdeen, South Dakota, the heat index was forecast to reach 103. Up in Marquette, Michigan, on the shore of Lake Superior, of all places, the heat index was climbing to between 105 and 110 degrees. When the coast of the coldest of the Great Lakes is running a heat index near 110, you are not looking at a normal summer warm spell. You are looking at an air mass with almost no boundaries. The geography of how this unfolds is worth tracing, because it explains why the danger keeps escalating instead of fading. The ridge set up first over the Great Basin and the northern high plains, which is where those all-time records fell on Sunday. Then it began to shift and expand eastward, spilling triple-digit heat across the plains and pushing hot air into the upper Midwest and toward the Great Lakes. By Tuesday, the leading edge reaches the northeast, and by Wednesday, it peaks along the coast. Each day, the heat is not just persisting in one place. It is advancing into new territory, into more cities, into denser and denser concentrations of people and air conditioners. A heat dome that starts over sparsely populated high desert and ends over the northeast megalopolis is a heat dome that gets more dangerous and more expensive to survive with every day it travels. And the ridge is moving east. This is the part that turns a regional heat event into a national one, because the high is forecast to build toward the Great Lakes and the Northeast, dragging its heat with it. The peak arrives midweek along the Interstate 95 corridor, the strip of cities from Washington to Boston where tens of millions of people live. Philadelphia went under an extreme heat watch, with the heat index forecast to reach as high as 108 degrees on Wednesday. New York City and southern New England fell under heat advisories, pushing toward 100. Chicago is looking at something near 105. Every one of those numbers is a demand for electricity, because every one of those numbers is a city full of air conditioners about to switch on at once. And the forecasters do not expect it to end quickly. The Weather Prediction Center's extended guidance calls for major to extreme heat risk to persist across the northern and central plains and the Midwest into late week, easing only slowly and then shifting south rather than simply dissipating. That word, persist, is the one that matters. A heat wave that lasts a day is a nuisance. A heat wave that lasts a week or more is a compounding hazard because the danger to human health and the strain on the grid both accumulate the longer it holds. Bodies do not get a chance to recover. Reservoirs of cool air in buildings get used up, and the demand for electricity does not spike once and fall back. It stays elevated, day after day, night after night, grinding against a system that has less and less margin to give. The American ridge is not a spike, it is a siege. Now connect that back to France, because this is the same equation viewed from the opposite side. In France, the heat attacked the supply of electricity, choking the plants that make it. In America, the heat attacks the demand, driving the need for power toward its ceiling exactly when the grid is under the most thermal stress. Supply and demand, the two ends of the same wire, both squeezed by the same enemy at the same time. Earlier this month, in our video on the record heat swallowing America, we watched an air mass so hot that the forecast models kept running too cool, under-predicting how extreme it would get. This is the sequel to that air mass, reloaded and aimed at the coast. There is a detail in the American data that most coverage skips, and it is the one that actually kills people. It is not just the afternoon high, it is the night that never cools down. In parts of the heat dome, overnight low temperatures are staying near 80 degrees, which means the human body gets no chance to recover before the next brutal day begins. Heat is the deadliest weather hazard in the United States. More than hurricanes, more than tornadoes, and it does its worst work in the dark. In the hours when the air refuses to release the day's heat and the power bill for staying alive keeps climbing. So the real question is not how hot the afternoon gets. It is whether the grid can hold through the night. And that is the question France just answered in the worst possible way. Here is where all of this tightens into a single, uncomfortable shape. And it is the reason the thumbnail on this video says the situation is far worse than you think. Extreme heat does two things to the electrical system at once, and the two things pull in opposite directions. On the supply side, heat weakens generation. It warms the rivers that cool the plants. It lowers the efficiency of every thermal power station, and it eats the margin the whole system runs on. On the demand side, heat drives consumption toward its absolute peak, because air conditioning is the single largest reason people flip a switch on a hot day. The supply falls and the demand rises, and they do it in the same hours, under the same sky, for the same reason. That is a feedback loop, and feedback loops are how systems tip over. Picture it as a bridge that gets weaker precisely as more weight is loaded onto it. On a mild day, the bridge is overbuilt and the traffic is light, so there is enormous slack. On a day like the ones France and America are living through right now, the traffic is bumper to bumper, and the bridge is losing steel by the hour. The margin that keeps the lights on is not a fixed thing. It shrinks as the temperature rises, which means the safety net is thinnest at the exact moment you are most likely to fall into it. And this reframes the entire way we tend to think about surviving extreme heat. We talk about temperature as if the number on the thermometer is the whole danger, but the thermometer is only half the story. The other half is whether the power stays on, because for most people, the primary defense against a lethal heat wave is a working air conditioner, and a working air conditioner is nothing without the grid behind it. Strip away the electricity, and a heat wave that was survivable becomes something else entirely. This is the deeper truth France just exposed by shutting those reactors. The binding limit on human survival during extreme heat may not be the heat itself. It may be the electricity, the fragile, temperature-sensitive flow of power that the heat is actively working to cut. Look at the timing of the demand, and you see why this is so precarious. Electricity is unusual among the things we buy, because it mostly cannot be stored at scale. It has to be generated in the same instant it is used. That means the grid is a constant, second-by-second balancing act between supply and demand, and it is built with a cushion of spare capacity to absorb the peaks. On a hot afternoon, air conditioning becomes the single largest driver of that demand. And when tens of millions of units switch on across a heat-stricken region at the same time, the load climbs toward the top of what the system can deliver. Now stack that against everything we just covered. The demand is peaking exactly as the generating headroom is shrinking, because the same heat that is running the air conditioners is warming the coolant and sapping the efficiency of the plants. Peak load and minimum supply arriving in the same hours. That is the definition of the moment a grid is most likely to fail. This is why the thumbnail promise is not an exaggeration, and why the real danger is worse than a simple hot week suggests. Most people picture a heat emergency as a straightforward thing. It gets very hot. You stay inside. You wait it out. But that mental picture quietly assumes the inside stays cool, which quietly assumes the power stays on, which quietly assumes the grid is not itself a casualty of the heat. Strip those assumptions away, and the danger changes shape entirely. A survivable heat wave and a lethal one can be separated by nothing more than whether the electricity holds. And the heat is actively working to make sure it does not. France just showed the whole world what it looks like when a power system starts making sacrifices to stay upright. The frightening part is not that it happened once. The frightening part is that it happened this early, in a summer the forecasts say still has a long way to run. The consequences of that failure are not abstract, and history is blunt about them. Heat is the deadliest weather hazard in the United States, and its lethality is tied directly to the nights. When overnight lows stay near 80 degrees, the human body never gets the recovery window it needs, and heat stress accumulates across days until it becomes fatal, especially for the very old, the very young, and anyone without working air conditioning. That is why the European death estimate this year lands where it does: 20,390 excess deaths, with a range from about 17,200 to 25,100, is not a projection of some distant risk. It is a measured toll on a continent that is now rationing the very power meant to prevent exactly those deaths. We have a number now for what that looks like when it goes wrong, and it is sobering. The heat across Europe this year has been associated with an estimated 20,390 excess deaths, with a range running from about 17,200 to 25,100. Those are people who would otherwise be alive, lost to a season of heat, on a continent where the power to cool them is now being rationed by the very temperatures that are killing them. That is the loop closing. That is the supply and the demand and the human cost meeting in the same place at the same time. So when I say this is far from over, I am not reaching for drama. I am describing the machinery. A single hot week is a hardship. A structural mismatch between a warming world and a heat-sensitive grid is something else. It is a problem that gets worse with every fraction of a degree added to the background, and the background is still rising. To understand why the pressure is not going to let up anytime soon, we have to look up at the pattern in the atmosphere that is holding all of this in place, and at the slow, enormous force in the Pacific Ocean that is feeding it. The reason this heat is so stubborn comes down to a single word that atmospheric scientists use with a certain dread: blocking. Normally, the jet stream keeps weather moving. Highs and lows march across the map in a steady procession, so a hot spell breaks after a few days when the next system pushes it along. But every so often, the jet stream buckles into a high amplitude, locked pattern, and a ridge of high pressure parks itself over a region and simply refuses to leave. When that happens, the heat does not pass. It accumulates. Each day stacks onto the last. The ground dries out. The air overhead compresses and warms further, and the whole thing feeds on itself. That is what a heat dome is. And that is why the American ridge is forecast to persist into late week and only slowly relent, and why Europe's heat has kept reloading instead of breaking. Europe's numbers make the persistence undeniable. According to the Copernicus Climate Change Service, June of this year was the hottest June on record for Western Europe, and the second warmest June ever measured for the planet as a whole. And June did not close the book. In early July, a fresh heat dome built back over Western Europe, with daytime highs running 10 to 15 degrees Celsius above normal, and the Iberian Peninsula and southern France driven into the low to mid-40s Celsius. On July 8th, Barcelona's Fabra Observatory recorded 40.5 degrees Celsius, roughly 105 degrees Fahrenheit, the highest temperature in more than a century of observations at that site. The next day, the United Kingdom logged 35.5 degrees Celsius, part of a record number of days above 34 degrees in a single year. Records are not just breaking, they are breaking, then being broken again weeks later. Underneath the stuck ridge sits the second engine, and it is one we talked about just last week. In our video on the El Niño now forming in the Pacific, we tracked a warming that has climbed faster than the models expected. The Oceanic Niño Index, the standard measure of how far the tropical Pacific has warmed from normal, now sits at plus 0.98 for the spring season, up from plus 0.51 the season before. That is a moderate El Niño, and it is strengthening, with 13 of 24 forecast models projecting. It could grow into a very strong event by autumn. El Niño acts like a thumb on the scale of the entire climate system, nudging global temperatures upward. And because that warming tends to lag by several months, the heat we are seeing now may be the opening act rather than the finale. It helps to understand what El Niño actually is, because it is one of the great engines of the planet's weather, and it works through a mechanism you can picture. Across the tropical Pacific, the trade winds normally blow from east to west, dragging warm surface water toward Asia and Australia and piling it up there, while cold water wells up from the depths off the coast of South America. That circulation of wind and water is the ordinary state of things. During an El Niño, the trade winds weaken, and that warm pool of water sloshes back eastward across the Pacific, spreading warmth across an enormous stretch of ocean surface. Warm water heats the air above it, and because the tropical Pacific is so vast, that extra warmth ripples outward and rearranges weather patterns across the whole globe. It shifts where storms form, where droughts settle, and how high the baseline temperature of the entire planet sits. The index we use to track it, now standing at plus 0.98, is a measure of exactly how far that ocean has warmed from its normal state. We have living memory of what a strong version of this does. The Great El Niño of 1997 and 1998, and the powerful one of 2015 into 2016, both coincided with record global temperatures, mass coral bleaching, and a cascade of floods and droughts scattered across continents. Each of those events pushed the planet's average temperature to a new high, precisely because the warming stacked on top of everything else already happening. And that is the concern this time, spoken plainly by the forecast spread. With 13 of 24 models projecting this, El Niño could grow into a very strong event by autumn. The warming it drives may not have even arrived yet, and it would be arriving on top of a baseline that is already, right now, breaking records without its full help. Put the two together, and you have your answer to why this is far from over. You have a jet stream pattern that keeps trapping heat in place instead of moving it along, sitting on top of an ocean that is steadily loading more warmth into the whole system. The ridge provides the immediate spike. El Niño raises the floor everyone is spiking above. Neither one is scheduled to fade in the coming days, which is precisely why forecasters are talking about the heat persisting rather than passing, and why the strain on the grid, the reactors in France, the demand in America, is not a one-week emergency, but the leading edge of a longer squeeze. And there is a quiet implication in the El Niño data that I do not want to slide past, because it is the kind of thing this channel exists to point at. If the warming lags by months, and if the event grows into a very strong one by autumn, as many models suggest, then the true peak of this may not even be this summer. It may be waiting in the year ahead. That is not a forecast I can hand you with certainty. It is an open thread hanging over everything else, and we will come back to it. First, we need to step back and see the shape of the whole thing, because 2 continents breaking records in the same week is not a run of bad luck. Consider the coincidence, and then consider whether it is a coincidence at all. In the same stretch of days, France is idling nuclear reactors because its rivers are too hot, and the United States is setting all-time temperature records under a 594 decameter ridge. Ordinarily, these land in different sections of the news. One a European energy story, one an American weather story, filed separately, read separately, forgotten separately. But they are not separate. They are 2 expressions of the same thing. A northern hemisphere, summer, running hotter than the modern record, with high amplitude ridging locking heat over one region after another. The pattern recognition here is the whole point. When you stop treating simultaneous extremes as unrelated headlines and start seeing them as symptoms of one condition, the picture changes. This has happened before, which is how we know it is a pattern and not a fluke. Europe has been forced to curtail nuclear output in past heat waves for the very same river temperature reason. It happened in the brutal summer of 2003, and again in more recent years as the continent has warmed. What is different now is the frequency and the reach. Since late May, national or monthly temperature records have fallen across an astonishing sweep of countries: Austria, Belgium, Czechia, Denmark, France, Germany, Hungary, Italy, the Netherlands, Poland, Romania, Slovakia, Spain, and the United Kingdom. That is not a hot afternoon in one city. That is most of a continent rewriting its record books inside a few weeks, and doing it while the grid that is supposed to cool everyone starts to falter. The thing that separates this from ordinary summer heat, is that the records are not standing alone. They are being broken and then broken again. Western Europe logged its hottest June ever measured, and then July arrived and pushed a fresh dome of heat right back over the same ground, driving Spain and southern France into the low to mid-40s Celsius all over again. Barcelona's 40.5 degrees on July 8th was the hottest reading at that observatory in more than 100 years of records. The United Kingdom, a country whose climate is practically a byword for gray and mild, set a record for the number of days above 34 degrees Celsius in a single year. When a single site beats a century of its own history, that is remarkable. When a dozen countries do it at once, and then do it again a few weeks later, that is not a collection of local anomalies. That is one enormous coordinated signal, and the coordination is exactly what the pattern-blind version of the news misses when it files each record as a separate weather curiosity. The heat over France that shut those reactors and the heat over America setting all-time records are the same phenomenon wearing two different postal codes. The heat does not stop at the power plant either. It spreads outward into fire. On the Iberian Peninsula and across southern France, the same conditions drying out the land have driven severe wildfire activity, because a landscape cooked for weeks under a stuck ridge becomes fuel waiting for a spark. And the same is true in the American West, where the heat dome is layered on top of a drought that already covers a huge share of the country. Nearly 30% of the continental United States sits in severe drought or worse. The figure is 29.99% of the lower 48 in severe drought or beyond. And one fire alone, the Babylon Fire in Utah, has burned more than 106,600 acres. Red flag warnings for critical fire weather are posted across the northern plains, where the heat, the low humidity, and the wind are converging at the same time. That convergence is its own kind of warning, and it is worth pausing on, because it shows how a single heat regime multiplies into several disasters at once. In parts of the northern plains this week, 3 hazards are stacking on the same ground on the same days: the extreme heat itself, the critical fire weather conditions of low humidity and gusty wind, and, on the edge of the ridge, the potential for severe thunderstorms. Heat, fire, and storms, braided together, all fed by the same stuck pattern in the atmosphere. A landscape baked for weeks loses its moisture. The dead dry vegetation becomes fuel, and all it takes is a spark, a lightning strike, a downed line, an ember on the wind, to turn a heat wave into a firestorm. This is the same script playing out on the Iberian Peninsula and in southern France, where the heat has driven severe wildfire activity across a continent already at its breaking point. The heat is never just the temperature. It is the temperature, plus everything the temperature sets in motion. Keep the through line in view, because it is easy to let a list of disasters blur into noise. Every one of these, the reactors, the records, the fires, the deaths, is downstream of a single regime of trapped record heat sitting over the northern hemisphere. The French reactors and the American demand spike are just the two places where that regime collides most directly with the machine we have built to survive it. The wildfires and the drought and the mounting death toll are the same regime hitting the ground. And that simultaneity, that sense of many systems straining at once under one invisible pressure, is exactly the soil where a certain kind of theory takes root. When people watch reactors shut down and records fall and fires spread all in the same week, some of them reach for an explanation bigger than weather. They start to ask whether someone is doing this on purpose. So let us take those questions seriously, one by one, and see which parts survive contact with the data. Because some of them contain a real kernel, and some of them fall apart the moment you look closely. The first theory arrives almost on schedule whenever a power plant goes offline. The claim is that the reactor shutdowns are deliberate, that this is a manufactured energy crisis, a coordinated move to ration power or force some agenda by making people cold in the dark, or in this case, hot in the dark. It is an understandable instinct. When the lights dim, it feels like someone must be reaching for the switch, but the data points the other way, and it does so decisively. The shutdowns were triggered by a specific, long-standing environmental law governing how warm the discharged river water is allowed to be. And here's the detail that dismantles the theory completely. The same government that let those reactors go quiet also issued an exemption to keep the Bugey plant running, deliberately waiving the temperature limit to protect the grid. If the goal were to engineer a blackout, you do not sign a waiver whose entire purpose is to keep a plant online. The action and the theory point in opposite directions. The second theory goes further, and it is one this channel hears constantly. The claim is that the heat dome itself is engineered, that some program, whether cloud seeding or a facility firing energy into the upper atmosphere, is manufacturing the heat on purpose. I want to treat this with the seriousness the question deserves, and then I want to show you exactly why the numbers forbid it. A continental heat dome is not a small thing to move. The amount of energy involved in holding that ridge in place is on the order of 10 to the 16th to 10 to the 17th watts. Human technology, at its absolute largest, operates something like 9 or 10 orders of magnitude below that. To put that gap in plain terms, it is the difference between a single drop of water and every ocean on Earth combined. Cloud seeding can nudge a cloud that is already primed to rain. It cannot conjure a hemisphere-spanning ridge out of nothing, because there is no machine, anywhere, that comes within a billion-fold of the required power. I want to be fair to the impulse behind that theory, though, because there is a real feeling underneath it that deserves an honest answer. When you watch reactors shut down, records fall, and fires spread all in 1 week, it is natural to sense that something is deeply wrong and to look for someone who is responsible. And in a sense, something is wrong, just not in the way the theory claims. The failure is not that someone engineered the heat. The failure is that we keep building our cities, our grids, and our safety plans as though this heat were not coming, when the forecasts have been telling us for years that it would. That is a failure of preparation, of imagination, of will. It is not a conspiracy. It is the far more ordinary and far more fixable problem of a civilization that has not yet taken its own data seriously. The third theory is subtler, and I have some sympathy for it. The claim is that they are hiding how bad it really is, that the official forecasts are sanitized, that the true danger is being suppressed. Here is where the honest answer is almost the reverse of the accusation. The forecasts are public, updated constantly, freely available to anyone. And on this heat event, forecasters have repeatedly noted that the models were running too cool, underpredicting the extremes, not exaggerating them. The failure, where there is one, is not a cover-up of how bad it is. It is a structural underpreparation for how bad it plainly, publicly is. The data is on the table. The problem is that we keep building and living as though the numbers on that table do not apply to us. The last theory reaches all the way to the ocean. The claim is that El Niño is being caused or steered for some policy purpose, that the warming in the Pacific is not natural, and this one collapses against time itself. The El Niño pattern is written into the coral and the seafloor sediment record going back thousands of years, an ocean atmosphere oscillation far older than any government, any agency, any technology. Its effects are often underestimated, and its details still surprise the models, but its cause is not manufactured. It is one of the planet's oldest rhythms, and this year it happens to be strengthening under a summer already primed to break. Scientists can read that rhythm in the growth bands of ancient corals and in the layered mud of the seafloor, which preserve the ocean's temperature swings across thousands of years, long before anyone could have interfered with anything. You cannot manufacture something whose fingerprints are fossilized in rock from before recorded history. What you can do is underestimate it, and that, honestly, is the real lesson buried in every one of these theories. Each one takes a genuine, visible strain in the system and assigns it a hidden author, when the truth is both simpler and heavier. There is no author. There is a heat regime older and larger than any of us, meeting a grid we built for a cooler world, and the physics grinding away in the space between them. No one is hiding the story. The story is sitting in plain sight, in the river temperatures and the reactor logs and the record books, waiting for us to read it honestly. The theories, in other words, are pointing at something real, a system under visible strain, and then attaching the wrong author to it. There is no hidden hand. There is a heat regime, a grid, and the physics between them, which leaves us with the only question that actually matters, the one none of the theories can answer. The question is not whether it is hot. We have established that, beyond any doubt, all-time records across the American West, the hottest June on record across Western Europe, a continent's worth of national records falling in a matter of weeks. The question is, what breaks first when the thing you rely on to survive the heat is disabled by the heat? France just gave us a partial answer, and it was not the answer anyone would have chosen. For 6 days, it decided to sacrifice a river to save a grid, waiving the rule that protects the water, because the alternative, losing the power, was worse. That is the shape of the trade we are being forced into. Not a dramatic collapse, but a slow series of quiet concessions, each one giving up something we used to take for granted in order to keep the lights on one more day. Watch the near-term thresholds, because they are the places this story will next reveal itself. The Bugey exemption expires on July 20th. If the ridge over Europe holds past that date, France faces the possibility of curtailing more reactors, or extending the waiver, or finding some third uncomfortable option, and every one of those choices tells us something about how much slack is left. Across the Atlantic, the American heat peaks midweek along the Interstate 95 corridor, where the demand for cooling will run toward its ceiling in cities holding tens of millions of people. Whether the eastern grid absorbs that load cleanly or hits its own version of the bind France just faced is a live question with an answer coming in a matter of days. And behind both of those, the slow force keeps building. The Oceanic Niño Index sits at plus 0.98 and climbing, with a meaningful share of models pointing towards a very strong El Niño by autumn. And the warming it drives tends to arrive months after the ocean signal peaks, which means the version of this we are living through right now. The reactors, the records, the rationing may not be the worst version. It may be the early one, The heat regime that shut down 3 of France's reactors and is now bearing down on America is not a storm that passes. It is a condition that deepens, and the infrastructure standing against it was built for a world that is quietly ceasing to exist. Think about what the trade actually costs as it repeats. France sacrificed a measure of river health to hold its grid together for a handful of days, and that was a manageable price this time, paid with a temporary waiver on a single stretch of the Rhone. But the whole danger of a feedback loop is that the price does not stay small. Each time the heat returns harder, the concession has to grow, more reactors curtailed, or longer waivers, or deeper cuts to the ecosystems the rules were written to protect, or, on the demand side, rolling reductions in power to the very people trying to cool their homes. There is a version of the coming years where the exemption stops being an exception and becomes the routine, where every serious heat wave forces another quiet decision about what we are willing to give up to keep the lights on. And with the Pacific still warming and the index still climbing toward a possible, very strong El Niño by autumn, the pressure that forces those decisions is not fading. It is loading. I keep coming back to the machinery, because the machinery is where the real story lives. We built the most reliable power sources in human history to be immune to weather, and this week, the weather switched 3 of them off without touching a single wire, just by warming the water they drink. We built our entire defense against lethal heat around a grid, and the grid turns out to lose strength on exactly the days the heat turns lethal. There is a grim symmetry to it that is hard to shake. The hotter the world gets, the more we need the power, and the harder the heat works to take it away. So here's the thread I'm going to leave hanging, the one I genuinely cannot resolve for you tonight, because no one can yet. France chose to heat a river to save a grid, and it bought itself until July 20th. The exemption is a bridge, not a solution. What happens when the next reload of this heat arrives? Over Europe, over America, over wherever the ridge parks itself next. And there is no headroom left to trade. What does a country give up when it has already given up the river and the heat still has not broken? That is the question the summer of 2026 is asking, and we are going to be watching very closely for the moment it starts to answer.